Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another banger question I have to say waiting for us today on Leetcode. So let's get started. So yep. So on today's question, we have to find maximum number of points from the grid queries. So first let's quickly understand the question from the problem statement iterations. So we have a n cross n matrix they have given to us, name as grid. So and they have given a queries of size k. Now these two things they have pre-given to us. Now find an array answer of size k. So the answer size and the query size are identical. For each integer queries I, you start from the top left cells of the matrix and repeat the following process Now what's the process? Now if queries of I is strictly greater than the value of the current cell that you are in, then you get 1 point if it is your first time visiting this cell, and you can move to any adjacent cells in the 4 directions, up, down, left or right. So if you are like standing on a particular index of particular point of a grid, of the given grid, then you can add a value, you can get a point of 1, if that particular value is strictly like queries of I is strictly greater than the value where you are standing at, so the value where you are standing at is smaller than the queries of I, and if and you are visiting that particular cell is the first time, so if you are like, if when you are processing a particular query, if you are visiting the cells, a particular cell multiple times, no, you are not going to get like n points to visit a particular cells n times. No, it is not the case. You will get a point 1 only the first visit, and what is the conditions you can visit altogether that particular cells? If that particular cell value, is smaller than the queries I, as simple as that. Now otherwise you do not get any points and you end this process. And yes, and if you are not able to do so, then you are not going to get any points and you can terminate your process. Now after the process, answer I is the maximum number of points, you can get for the queries I, and points we have just discussed how we can get the maximum points. So how we can get 1 point and how we can get maximum points, we will understand when we are iterating over the test case. Now note that for each query you are allowed to visit the same cell multiple times. So that is for note purpose, but I have to say that is like a useless statement. That is not going to help at all. Like visiting a particular cell multiple times is not going to help at all. That is like for completely like the way basically the problem stater want to divert you. So don't get to this particular question, because when we know we have to maximize our point and we know we are going to get a points only when first time we are visiting a particular cell, then no matter like, so that is completely useless to basically visit a particular cell multiple times, and ultimately return the resulting array answer. And finally we have to return the resulting array answer. So now try to understand the few of the test cases they have given to us. So that is the grid they have given to us, and they have asked for queries 5. So for queries 5, starting from the top left, which of the cells, like you can go on the 4 directions they have mentioned, right? Somewhere they have mentioned, so you can go up, down, left and right. This 4 directions movement is allowed on this particular test cases. So if I am standing at the top left corner and I have to move 4 directions, so basically a BFS or DFS kind of traversals is for sure, so we have to do because that is very standard grid traversals things. We should do with BFS or DFS things. And what is these things? What is the cells we can visit starting from the top left? So you can see, like, can we visit 1? Yup, because 1 is smaller than my 5. So I have a upper boundary of 5 when I am processing the query for 0th index. So I have upper boundary 5. So can I visit 1? Yep. Can I visit 2, 3, 2, 3? Everyone is valid, but I can't visit 5. So this I am not able to visit because my upper boundary. So which of the cells I am visiting that are strictly lesser than my queries of I. Correct. Now another thing is, can I visit this one? Ideally yes, because 1 is strictly lesser than my queries 5. But how I can visit? I, starting from the top left, I should be visit bottom, right, left and up. So here you can see from 2 from these two or from these three, you are not able to go further. You are not able to go further for queries 5, because on that case you are going to encounter a value which is greater than or equals to your query, so that is not allowed. So like this way, you are not able to visit a one which actually smaller than your queries I, but it is lying at certain points. It is basically surrounded by some values which is basically violating your entry to this particular cells, which is basically violating your entry, or basically allowed to land on this particular cells that you can't do. So that is the case, right? Now so now for query 6, so for query 6, you can see that you will visit all of them except this 7, right? Because 7 is greater than or equals to your queries, you will visit which are strictly smaller my queries of 1, like that is of 6. And for 2, you will only visit 1, because other all are like more than or equals to your query. And this one again surrounded by some values which is not allowed to visit this particular cell altogether. So here you can see for 5 we are able to visit 5 cell uniquely. So my point I am going to collect is 5. For this 6, I am able to visit this all 8 cells. For this 2, I am allowed to visit only 1 cell. And there is another test cases where they have basically asked for this grid queries 3. No. Can we altogether land on this 0, 0, No. Then on that case, are we able to make anything to our answer? No. So that's the reasons we can't visit any of them starting from the top left cells, which is already greater than my 3. Right, so before we are starting, I have to say that is obviously now let's take a look, then only I can give you why that is a quite interesting question. So your m and n can go to 1000, but your m cross n, that is the number of cells on your grid, is as big as 10 to the power 5, and your queries of I is like 10 to the power 6. Sorry, your k value, like your query's length, is as big as 10 to the power 4. So if you are basically thinking like for every query I will start from my top left corner, for every query I will start from my top left corner, and I am going to iterate every of, like I will explore how many of I can explore by following the formula. So but no guys, because on that case, if you are able to visit all of them for a particular query, and queries are state like this, for every query you are able to visit all of them. So for every query, how many cells you are going to visit? 10 to the power 5 cells. So for 10 to the power 4 queries, how many cells you are going to visit? 10 to the power 4 into 10 to the power 5 cells. That is going to be a 10 to the power 9 cells. 10 to the power 9 time of complexity. And as we all know, we can do 10 to the power 8 at max time complexity we can hit if we want to get an AC in 1 second computation power. So nope, that is not going to give us that things. But yeah, like I also just implemented, and initially I basically take a look that is can grow as 1000. So if it is 1000, then I think we are good, because 1000, like 10 to the power 4 into 1000 is 10 to the power 7. So basically I think that m cross n is can biggest in 1000. So that is of 1000. So if that is the case, then those standard brute force should work. But yeah, I have done the standard brute force which I got at TLE. So you can go through this. I will also give the standard brute force code also. So here you can see that we are calling for every queries, we are calling our helper functions, and for every helper functions we are doing standard DFS, no super magic. We are doing standard DFS only, and we are visiting that cells, and we are returning count how many cells we are to visit. But that is not going to help, because that is going to be give us for sure TLE. So now basically think of like the optimal solutions for this particular question. But before we can jump, so that is a hard tag question, so please expect like that is going to be a master level question for sure, and you have to basically done your brainstorming very vigorous to basically get a good algorithms which is basically work for like very good time complexity. But yeah, like that is I have to thank to my wife basically. So the main algo or the main architectures, like how basically we should have to like structurally iterate on the grid, that particular things is came to my wife brains only. So I have to say a big great job like on this type of like thinkings on this particular problem. So that is quite good. Yeah, so now basically try to understand the how we can do the things, like process our things in faster way, better than our brute. Yeah, so let's go to the one node. So now if I can ask you, like just by seeing the problems, what is the first things is coming to your brain? So we should have to be a somewhat kind of greedy, because if our queries, they are asking, so I know our queries are haphazard, but if you think that what is basically blocking to explore all the cells, so for this one I know I have a power of 5, but I am not able to visit this particular one, so which is basically blocked me to do so, because my ability to explorations further, so if I am exploring for a particular query, and let's suppose I have given only one query to you, so you can easily get back to me with answer. But if I am giving you the second query, so is there any dependency on the first query? Can you tell me, is there any dependency on the first query? If you already have processed a query, which I just given you, is there a dependency? Or more specifically, I have to say, which is the ideal case? You have to do less computations, like on the second query. Okay, then you will basically tell me that okay, like if the second query is more than the first query, is what you have given to me, it is more than my first query which you have given to me, then I can think of some optimizations, because for the first query I have already explored some of the cells, but further explorations I am not able to do so, because I have the rigidity of the limit, but on the next query, as you are stating that on the current query, what is the query you have last processed, this query value is bigger, so I have the liberty to explore more cells. So how it is, let's go to our OneNote. I know it is going to be a super tricky part, but yes, it is what it is. So अरे यार इसका भाई स्टार्ट हो जाता है, अरे लिखना पड़ रही, अच्छा पेन अब चल रहा है ना. So let's suppose if I have given you a query of x, and let's suppose with query x you are able to visit this, but not somewhere. Now I am what basically blocking you to visit these cells, which is what basically blocking you to visit these cells, which I marked as crossed, which basically blocking you to visit that particular cells. So that is right, obviously. So because my this cells value is what, maybe greater than equals to my x, so that is basically blocking. And now with the next query of y, which query I have thrown, can you show some optimization? Do we need to visit this which are already green ticked, again? Do we need to visit them again? Can you state me? Can you tell me? Nope, we don't have to do, because we are thrown by a query which is greater than the previous query we just processed, and we know this query is bigger. So for these cells, for which cells we just visited, for that whatever the answer we have had, that is going for sure to my answer, that is going to be for sure my answer. And what is the extra? Can this be a possible? Now because we have the liability now to use y, and for y maybe, let's suppose for this we are not able, because on this cell value, let's suppose C1, this let name it C1, C2, C3, C4. Let's suppose for C1 is greater than or equals to my y. Okay, I am not able to visit C1. For C2, okay, C2 is again a bad guy, I am not able to visit. But for C3, let's suppose C3 is my smaller than my y, then can I visit him? Yes, I can visit. So whatever the answer till now I have added to the last cycle run. So this entire portions I can add one more, this guy to my answer. And let's suppose for C4 is also a good person, or C4 also is less than y, so I, for y I am, what is for x, let's suppose answer for y, it is y answer plus two more, because I am able to explore two more. and like this way, if I have z which is greater than my y, which is greater than or equals to my y, anything fine. So I know I have already processed, I have processed these cells, which of the cells I am marking na. So or maybe I can quickly draw the things again for you. अरे यार पेन तो पेन हो क्या भाई लोग, यार पेन गया मेरा, चलो यार हाथ से थोड़ा ट्राई कर लेता हूँ, बट यार माई पेन हैज डैमेज्ड, so I need to bring another. So let's suppose that is the grid is given to us, and I am doing from hand, so not able to maybe make it too much clarity to you, but yeah, mostly I think we are good. So that is the grid, and these particular portions which I am highlighting, I am already visited. I have already visited these particular portions. Let's suppose I have already done the explorations, and I right now I am standing a z, which is I know is greater than the y, which I just processed. So these cells for y I am not able, but for z, maybe this turn to be a green, maybe this turn to be a green, maybe this turn to be a green cells. How it is green? So for these cells, maybe this cell value I can write it as a C4 is smaller than my z. So like this way, if the queries are in the order, now tell me, if my z value is smaller than my z value, then do we have any benefit? No, I can't use the y value, because for z we again have to reiterate from the very start cell, so that is the power actually. I can do some kind of queries modifications, and what modifications? I think it is very simple. Like if my queries are sorted, then only I can reuse my answer, which is just previously I have computed. So that is actually the main thinking powers you have to implement to basically figure it out. And implementations, if you had like on a or I am assuming, like if you are practicing this question, so BFS, DFS, Heap, main Heap, max Heap, so these are like a cakewalk type of things for you. So but again, like if you are not able to understand any of the particular piece of my code, then please do comments. I will happy to make a separate video for that. But yeah, now that is actually the like eagle eye you have to put on these particular questions to that basically make your known algo to fit on this particular question. Yeah, so now let's go to our this particular things now, code block. Yeah, so just basically what I explained, I did the same things as it is. So I have started with so that is basically my n and m, the row value, max row and max columns we have it, and we have started with a visited, and we have sorted our queries and put it in a query list. Why I didn't do in place query sort? Because we have to return our answer in the order of the queries is given to us. So we can't distort our query, we can't distort the order of the queries. We are only allowed to play our game with some sorted versions of my queries, but for returning my answer we again need the queries. So on that part, my queries should be the order they have given to us. So for our purpose, we have put it in a QL query list, like sorted query list, by making it a shallow copy of that particular queries, and it is the shallow copy with sorted order, and then I have pushed it to a heap. Because why heap? Because what we need, like when we are processing a particular query, and let's suppose we have done explorations point A, B, C. So now, to allow a particular queries to a good state, what we need? What is the minimum further explorations we can do? What is the minimum further explanations is altogether greater than or equals to my queries of I which I am processing, then do I am able to explore this altogether, any of them altogether? No. So that's the reasons I have taken a heap. So heap basically giving me what is the shortest, what is the minimum explorations value I can make, because I am super greedy. Because if I am not able to explore what is the minimum explorations I have it allowed from a particular cells for a particular query which I am processing. So if I am not able to explore that, then how I can explore further? Nope, I am not able to do so. So that's the reasons I have put heap push to the. Initially, we all know we have to start from grid 0, and we have pushed x and y, as simple as that, and we have HP. Now answer, we have start with an answer map with int. So that basically store for a particular queries of I, which all we have visited, what is the number of cells we have visited. So that is basically stored in our answer. So So let's suppose for 5, how many we have visited. We have from starting from very start, we are able to visit 5. So that basically our answer is going to be stored. A frequency map. So if your query our answer of queries of I, then you will get your answer. Its key is the queries of I, and its value is the output value. So that's the reason I have named it as answer. So let's just make a little bit more attentions. We are just need to do a final iterations only now. So what we have at now, we do a standard BFS kind of things. I have to say, we push, we mark visited 0, 0 and 1, and initially what is the last answer we have built, because we just saw, right, we need the last answer. We need the last answer because the new answer is basically just the last answer you are able to build, plus for this particular query solving, what is the extra you are able to build. So including that is your final answer for this particular query. So you need the last. So that's the reason I put last as 0. So because still now we are not able to build any of the answers, so our last is 0. Now we are iterating to our sorted query list. So QL is the sorted query, and so this part I will be coming next. So we pop the very lowest value from our heap. We didn't pop, we just basically assign to the very lowest value to our heap, and we are checking if my each value is altogether smaller than my lowest. So am I able to explore more cells? No. So on that case, for this answer of each, what is the number of explorations? The last number of explorations what we have at. So that is going to be my answer. As simple as that. And if it is not so, I think then we have a game to process. So here basically what is the extra cells we can visit. So we stored it in here variables. Now we are doing standard BFS, I have to say here, and we checking while our len of HP, and if altogether my HP of 0, 0, that is the very start things, is less than my each, only on that case we are allowed to process. And if that is not so, then we are doing standard break. Then on that case we are doing standard break, right? As simple as that. Now what we are doing, here plus equals to 1. We are doing here plus equals to 1 because we just have someone which is basically smaller than my explorations list. Explorations list is basically stored on my heap. So that is basically my explorations list. So these all are smaller than my each. So then I have added them. So I consider that for this particular I get an extra. So here basically my extra. So I have increased my here, and then I have popped the value from the heap. My heap. The first one is the value, second one is the x and y, and I am doing the standard 4 directional go, up, down, left, right. And if I am checking here, if I am not going to go out of boundary, and I am checking if this particular cell is altogether not visited, because we know multiple visitations to a particular cell is not going to help at all to our answer. So that's the reasons initially I told you. So this node is basically useless node. There is no node to take, right? Now you are marking this visited to be 1, and we are pushing the values to our heap of grid of x dx, y dy, what is the value, and the indexes. As simple as that. I am doing a standard BFS, very standard BFS, but here I have used what? Heap, because we are not using queue, because for standard BFS we are using queue, but here I am wrote the exact same code of the BFS but with heap. The reason is because we need the very minimum. What is the very minimum value? If we are not all together explore the very minimum value what is stored in the heap, do we able to explore furthermore? No. So we are doing standard break from here. And finally our last is going to be updated with what is the extra here. Here means extra. What is the extra we have visited? So last is going to be updated with plus equals to here, and our answer of each is we are finally storing our answer of last. As simple as that. And for next query, our last is altogether updated. Because we have added the here to our answer. Right. So now so one part I think I have missed. So this particular if block. So why we need another hard-coded checks? Because your heap is altogether going to be empty. And on that case you are like basically get and runtime exceptions. I think I also got this. If you can go to my submissions here just basically last submissions of AC, I got this. So that is something like this. So if you have everything as processed, like if a particular query is throw a very high value, then on that case, and if it is a consecutive, like let's suppose for this particular cell I have given 8 and 8 consecutive times, 8 and 8 consecutive times. So for first 8 you are able to visit, you are going to visit all of the cells, because for the first eight you are visit all of them, because all of them are smaller, and for next 8, where you are going to be, you are going to just pull directly from your heap. You are just going to pull directly from your heap, but your heap do have any value? No, because you have already done your BFS entirely, and your heap don't have any value basically to process further. So on that case, you are basically checking. If your heap is altogether empty, don't do anything. What is the last you have? Just put it in answer and then do continue. As simple as that. Right? So your answer, so like this way your answer is ready, and when your answer is ready, do we have anything pending? I think of small minor things. We have to return our result to the order in which the queries are asked for. The order the queries are asked for. And we know our answer is basically holding for queries of high value. We just need to just push to a resultant things, and we can return to make the things in the ordered fashion, to return our answer in the ordered fashion. So we are iterating now on our final queries, so which is basically provided in here altogether to the parameters. We are iterating on the ordered queries, which is, so that's the way we are not going to return our answer in arbitrary order. We will return our answer in the structured order which they have asked for. So we are iterating to our answer, iterating to our queries, and we know we have to push something to our result for this particular query, and we know where our answer stored, where our result stored. Basically our result stored is answer of each. We can directly make a call to our answer of each, and we will get our things and we will push it and return. As simple as that. I think you guys are able to understand, but again, like this actually the brain of this particular question is these particular iterations, these particular things. So please go through these particular sections of this OneNote explanations when we like that particular sections of the video. If you are not able to understand on the first go, please go to that particular sections multiple times, and once you got this now, and rest of the things I think is pretty standard implementation, right? Yeah, so that I have to say the most optimized time and space complexity for this particular solution, so which I am able to think of. So yeah, now let's quickly discuss the time complexity. So on time complexity, what we are doing, we are basically visiting everyone, right? We are basically visiting everyone only, that's it, right? So we are iterating to our queries, and for every queries iterations, we are basically not visiting our already visited cells. We are not doing that. We for every queries we are basically visiting them. We are basically visiting who are not visited. So that things can take I have to say some kind of what. So initially we are doing an n log n by sorting this. So that's the for sure of big of n log n plus we are iterating to our queries here. So we are iterating to our queries, and inside this I think to like pinpoint the time complexity is very tricky, but you can state a kind of big of what can I say, like a big of log n kind of things, but this log n, this capital N is going to be happening on 10 raised to the power 5 things, because your n cross m is grow at biggest 10 to the power 5. So that you can say, but this is not going to be correct. I am taking a very high limit, because for every query maybe we are not going to visit every of them. Because we are doing the pre-processing. If answer is altogether handy, and if we have already visited our heap, then we are just pushing our answer. We are not going to, so that basically things is basically taking the time. So we are not going to do this. And if if it is altogether lesser than my lowest, then also we are not going to visit any of them. So that is like very worst case, but I don't think that case is going to be occurred at all. So but yeah, you can mention, and after that we are doing a standard query iterations again. So that is going to be another big of it. And on space part, are we using any space? Yes, so for query list we are using big of n, we are using visited, that is of again big of n cross m, right? And we are using heap, that is again big of n. We are using answer, which is another big of n. So we are using space also a lot. Let's write 1n, 2n, 3n, 4n. Yeah, like that you can write it as a 4n time of complexity, 4n something. And apart from that, we are not And yeah, like results too, we have to make. But yeah, if you consider results, then another n. But I don't think like answer for answer you that is your output of this particular functions altogether. So answer you can skip, but 4n or 5n time of complexity you can tell, or that is amortized to be big of n only, and on time complexity we are running on big of n log n. Yeah, so that is the most optimal time and space complexity, guys, that I am able to think of. And if you are able to understand, like I have to say that is obviously a master level solution, and explaining this particular solution and understanding also, like to understanding this particular solution is like a superior level things I have to say. But if you are able to understand, so I have to say you are a very good state to like for your next interview. Till this point, please do subscribe to our channel, and please share the videos to your friends who are basically preparing or brush up their DSL skills, and please share the videos, that is basically help. So that's the reasons they are also going to get most of that you are doing. So please do, and please turn on the notifications when we are going back to our next video. So that's it, guys, that's it for today, and happy weekend, happy long weekend, and enjoy to your family. That's it for guys today. Bye.